In this video we're going to have a very quick look at recursion. Recursion is a method of solving problems that involves calling upon itself. The idea is that it will make smaller and smaller and smaller versions of the problem until it eventually reaches a definite result. An example that I'm going to use here is called add up, and basically this is where somebody says to you, what would be the sum of the integers if you had, for example, from 3 down to 1. And we're going to try and provide the solution to this using a recursive algorithm. So I'm going to start straight away. I'm going to declare an integer n. I'm going to make it 3 and another variable called answer. And then what I'm going to do is say that answer is equal to add up. And I'm going to do an iterative solution first, just so that I can check and compare. And then I'm going to print out the answer. Next thing I'm going to do is I'm going to make this subroutine. This is a function. I'm going to do it using the shortcut for NetBeans, much quicker. And so this is going to return an integer. You can pause the video if you want to do that yourself. Okay, I'm going to have an integer called total here. I'll make it equal to 0 initially. And what I'm going to do is I'm going to have a for loop. And I'm simply going to make it go from 1, in fact I'll leave it at 0, and go up to less than or equal to n, and I will make total equal total plus the looping variable, and then I will return total. This is an iterative solution. This should be there should be no surprise in this one. I'm going to run this and it should bring 6. So there's the answer, there's 6. 3 plus 2 plus 1. If I change that to 10, the answer should be 55. And so on. Okay, so I'm going to put that back to 3. Now, what I'm going to do now is I'm going to try and devise a recursive solution for this. And I'm going to do that just by making another subroutine called add up. And once again, I'm going to use the shortcut to make this. Okay, so with a recursive solution, we tend not to use loops. We use an if statement, and so here I need to identify the case where if somebody said add up all the numbers from n all the way down to 1, and what do they all equal? And if somebody said, like, well, add up where n is 100, you'd go, oh, I'm not sure. But if somebody said add up 1, then you'd say the answer is 1. So here, if n is equal to 1, then I know that is the one time that I can say the answer is 1. And this is called the stopping condition. However, for any other number, we need to have an else clause where we will call upon the function itself. So I'm going to return, and I'm going to carry out a recursive call. So I'm going to have add up and then something else here. But if somebody said to me, what is add up 5? Then I would say, well, I'm not sure, but add up 5 is 5 plus add up 4. Add up 3, for example, is 3 plus add up 2, a smaller version of itself. 2 is 2 plus add up 1. Now 1 is actually 1, where it reaches the stopping condition. So here, what I will do is I'll say, okay, I'll return n, which is the big number in the brackets, plus a recursive call on 1 less than n. And so here, eventually, this will go down to the point where the value inside the bracket, the parameter, is equal to 1, and it will return 1, the stopping condition. It has to eventually reach this position here where n will be 1, and we'll achieve that. So I'm going to run that now and see if that works. And there we go. So that's confirmed that that's correct. So here is the comparison of an iterative solution to a recursive solution. I'll do one more example where I'm going to count all the letter A in a given string. Okay, so my intention is to make a function which is called count a, and it will count the number of lowercase a's in a given string. So here it would return 4, hopefully. So I'm going to make an integer called answer, which will hold the result, and I'm going to make answer equal, I'm going to say count a iterative, and I'm going to pass in the word, and then I'm going to print out the answer. Once again, I'm going to use a shortcut to create that method. Bear in mind, this is the iterative solution. So pause the video and see if you can solve this. Okay, I'm going to declare a variable called total equal to 0, and then I'm going to loop through or iterate through the word, and there's a couple of ways I could do this, but I'm simply going to say if word dot, I'm going to use char at I is equal to a, then total plus equals 1. And then finally, underneath the for loop, I'm going to return total. Okay, so that's the iterative solution. I'm going to run that to see if it works, and it's provided me with the answer 4. I'm going to do the same thing again. I'm going to copy these two lines, and I'm going to try and provide a recursive solution. Now, bearing in mind we need to have a stopping condition, what could the stopping condition be? In other words, what string definitely doesn't have any a's in it? Stop the video, have a go at the code. Okay, so I'm going to type if else here and tab this, and I'm going to say if the word length is equal to 0, then it definitely doesn't have any a's in it, so I'm going to return 0. Else, I'm going to start with an if else here, and I'm going to tab this, and I'm going to say, okay, if I have encountered an a at the 0th position, so what I'm going to do is I'm going to say if word dot char at 0 is equal to a, then I need to return 1 plus count a on the word starting at position 1. So basically here what I've said is, okay, if the first letter of a word is a, then I'm going to have 1, and then I'm going to count a on the remaining shorter string starting at position 1. Otherwise, if the first letter wasn't an a, I would simply say, okay, well, okay, the first letter's not an a, then I'm going to simply do count a on the remaining part of the string. So this is the stopping condition, and here are the two possibilities of finding an a at position 0, and then here this is not finding an a at position 0. Okay, and that should cover all eventualities. Let's run that and see if that works. And that does work. So here is the recursive version, and here is the iterative version. Thanks for watching. See you later.